of a substance that contains as many particles or entities as there are atoms in exactly 12 gram of 12C isotope. Second law, law of definite proportions. It states that a given compound always contains exactly the same proportion of elements by weight. Compound from any source, either natural or synthetic, contains same amount of elements in the same ratio. For example, carbon dioxide present in air or the carbon dioxide we synthesize in the lab by heating coke or from any source of carbon dioxide. It always contains carbon and oxygen in the ratio of 1:2. The third law, the law of multiple proportion. It states that the two elements can combine to form more than one compound with a fixed mass of the other element. They are in the ratio of the small whole numbers. Let me take an example. Hydrogen and oxygen combine to form two compounds. One is water, that is H2O, and the other is H2O2, that is hydrogen peroxide. In H2O, the 2 grams of hydrogen combine with 16 grams of oxygen. In hydrogen peroxide, 2 grams of hydrogen combines with 32 grams of oxygen. Now, the mass of the hydrogen is fixed. Now, let's compare the ratio of oxygen in the two compounds. In water, oxygen is 16 grams. In hydrogen peroxide, oxygen is 32 grams. 16 is to 32, the simple ratio 1:2. Fourth law, Gay-Lussac's law of gaseous volumes. It states that when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same pressure and temperature. Last and the fifth law, that is Avogadro's law. It states that equal volumes of the gases at the same pressure and temperature should contain equal number of molecules. Dear children, it was well established that matter is made up of indivisible particles, atomios, that is, atom. Dalton proposed his atomic theory. Let's see what are the postulates of Dalton's theory. First postulate, all matter is composed of small, indivisible particles called atoms. 2. All atoms of a given element are identical in mass and properties. That means atoms of the same element are identical, but the atoms of the different elements are different. Third, the compounds are formed by the combination of two or more atoms in definite arrangements in the ratio of small whole numbers. Fourth, atoms are not created or destroyed or converted into any other kind of atom during a chemical reaction. They are simply rearranged into a new compound. Atomic mass and molecular mass. To do the chemical calculations, we must know what is it? Atomic mass. It is defined as a mass exactly equal to 1/12 mass of one carbon-12 atom. Why we are using this carbon-12? Because we know that there are isotopes of carbon, C12 and C14. Here we are considering the isotope C12. Molecular mass. It is the sum of atomic masses of the elements present in a molecule. Ways of expressing concentration. We do experiments in the lab and we prepare solutions. To prepare a solution, we express concentrations. Now let's see what are the ways how we can express these concentrations. Mass percent. It is obtained by using the following relation. Mass percentage equals to the mass of the solute divided by mass of the solution into 100. For example, there is a solution which contains 5 gram of glucose. We have to calculate the mass percent of the glucose, then how will you calculate? 5 upon 95 plus 5 into 100 because the rest amount is water. Molarity. It is defined as the number of the moles of the solute in 1 liter of the solution. Just see the formula. M is equals to the number of the moles of solute divided by volume of solution in the liter. Here you can see that molarity is depending upon the volume. Molality. It is defined as the number of the moles of the solute present in 1 kg of solvent. It is represented by small m, whereas molarity was represented by capital M. Now let's see mathematically what molality is. M is equals to number of moles of solute divided by mass of solvent in kg. Molality is mass dependent. It's very important to know the difference between molarity and molality. Molarity is depending upon volume, whereas molality is depending upon mass. A very common question, what is the effect of temperature on molarity and molality? Dear children, molality is independent of temperature because it is depending upon mass. When we change temperature, mass does not change, so molality does not change. But in case of the molarity, since it is depending upon volume and volume changes with the change in temperature, for example, if we increase temperature, volume also changes. Volume increases, so the molarity decreases. Limiting reagent. The reactant which is present in the lesser amount as required by a balanced chemical reaction gets consumed first and limits the amount of the product formed is called a limiting reagent. Let me explain. Just now I have explained that what are the rules which govern the combination of the elements and the formation of the compounds, the postulates of the Dalton's theory, the mole concept, and how we can express the concentration. I hope it is all clear to you.